Hey everybody. Hey everybody. Sorry. So yeah, we'll go on ahead and get started here. I guess first thing before I dive into my dive into the announcements and presentation, if you guys want to follow along with what I'm doing, if you go to picoctf.com and go, or I believe .org, sorry, and make an account, we'll solve like about 3 CTF challenges. So if you want to kind of follow along with what I'm doing and how I, approached a couple problems, you're more than welcome to do so. But I guess I'll go ahead and get started with announcements here. Whoops. Okay. So firstly, our social media handles, the gratuitous plugs. follow us, please. So yeah, I guess just to recap for any new people, Discord is usually where we post announcements or events. So you're more likely to find information of where our events at there. Of course, we still do update other social media handles, but a lot of it is done through a Discord. Membership is free, or the only real requirement to actually be a member at ACM or of ACM is just attend 20% of the meetings each semester, and there's roughly about 75. So you only really need to attend 15, and about 15, and that's not really a huge number because we have meetings quite often. But I mean, aside from that, there's no other requirements as long as you just sign up and attend 20% of our meetings. And of course there are benefits to being a member, like you get your own, you get a T-shirt, you get to participate in giveaways and so on and so forth. And I guess now just a couple of announcements for upcoming events for the next week or two. So we've got our Code Quantum Hackathon coming up this weekend. It's a hackathon that is for primarily or to support marginalized gender groups, but we'll just have this on the weekend. But it's pretty exciting, and if you're into hackathons and you want to make something in a small period of time, I encourage you to sign up. So on the 21st, so tomorrow, we're having ACM-W is having a day in the life of an HEB software engineer. Of course, as the title says, it's a little bit more than that. But if you're curious about how things work there, well, join us tomorrow, 3 to 4 p.m. at the Mesquite Room. That's SU 2.01.24. And there's free food because everyone likes free food. Nobody can complain. And so we also have a ICPC, which is competitive programming. We typically we solve competitive programming problems every week. For this week, because so we actually don't have a room for ICPC yet, so we'll try to keep you guys updated. So make sure you stay tuned for that if you're interested. But yeah, I guess. Oh yeah, and if you want to sign into today's meeting, I'll go ahead and give you guys a second to scan the QR code. Yeah. I don't know if I went too fast on the previous slides. Does anybody else need a QR code on some of the other ones? Oh, it's closed. Yeah. Who should we?
It's the intro to tech one. So I'm going to open it up right now.
Sorry about that, guys. I guess meanwhile that's going on, I guess I'll just go ahead and start presenting if that's fine. It's fine? Okay. And yeah, I guess so I feel like the title might be a little off, but today I mostly want to talk about what kind of CS skills you should have, or I would recommend you have when you're doing capture the flag events. But although it is a suggestion, for people who are interested, I still want to provide a nice introduction for them. And maybe they're curious and maybe they really want to do one, but they don't know how to get started or where to approach it from. So that's mostly why. So I guess the title might be a little bit a little bit might have different meanings, but main purpose is to just teach you how to get started, whether you're a CS student or not, or maybe you're another field entirely. But go on and get started here. So for context here, what exactly is capture the flag? So essentially what capture the flag events are, you have a series of cybersecurity challenges, and your job is to solve them. And typically, you'll know when you've solved the challenge when a flag appears, and it'll have a unique format. Depending on what event you go to, they'll tell you the format of these flags. And typically, the way you get these flags is that there's some vulnerability in there, or there's some trick that you kind of need to go through a methodical process to figure out. And it's a lot of fun. It can definitely be quite interesting. And so there's usually two primary types of capture the flag events: Jeopardy capture the flags, and attack and defense capture the flags. So we're going to go over the Jeopardy style events in this presentation, but I feel like the attack and defense ones do deserve a mention here. I mean, essentially, in attack and defense, what you do is you try to defend. So I believe you're on a set of virtual machines, and you're trying to defend your virtual machines while attacking other virtual machines and finding exploits on theirs. It's a lot of fun as well. But I guess whether or not you want to do attack and defense or Jeopardy is up to you. But I think both have both. I would say both are pretty good. But continuing on, kind of what I described a little. So I didn't really talk about what exactly they mean, but essentially Jeopardy capture the flag events. So they have kind of a variety of topics that they'll have their challenges under. So you might have challenges under web exploitation, where you try to go to a website and you find some something that might be wrong. Like maybe it's vulnerable to a cross-site scripting attack, or maybe you can modify the headers and get some network data that reveals the flag. And then there's also other challenges like binary exploitation and reverse engineering, which I'll talk a little bit about here in a minute. And then you have some other challenges which are a bit rarer, like for example, like programming challenges, hardware challenges. You won't really see that much. Same thing with steganography. You won't really see those often, but you'll still find them from time to time. They're just not as big of staples in these events as these other categories are. So I'll go ahead and So why exactly do you want to play these games? I mean, might seem kind of silly to just bang your head against the wall, and you might think, oh, I'm challenging myself for no reason. Well, I mean, firstly, it might be fun, maybe. I mean, maybe you like to torture yourself or not, or maybe you do think it's fun. I guess it's up to the person. But really the main thing here is that these events are for people to learn about cybersecurity topics or different types of exploits and vulnerabilities and techniques. And this is really nice because it really gives you an opportunity to hone and train your skills, which is quite valuable in getting a job or getting employment or getting internships. Employers will see, oh, hey, he's participated in these events, and he really cares about trying to solve these problems, and he's interested in trying to solve these in this field or in this sector. So definitely CTFs give you the ability to grow and learn your cybersecurity career, but also, like I said, opportunities with employers. But also, a lot of these challenges actually emulate like real life scenarios, and that's really nice because once you kind of get the idea of how one vulnerability was spotted and exploited, you might find another vulnerability in the wild in some piece of software or internal company, source code. Like you might find an exploit that you might not have known otherwise if you didn't do capture the flag events. So just having these knowledge of these unique vulnerabilities will help you in the field too, since they're often emulated by real life vulnerabilities or exploits or scenarios. So what I'll do now is I'll kind of talk about each topic individually. So binary exploitation, so typically in these challenges, you're given some sort of you're given some sort of program to run, and sometimes you are given source code. Kind of depends. But what you do in these programs is you try to go through and find a vulnerability. Like for example, maybe there's no like input validation. So maybe it isn't checking your inputs. And you can use that to your advantage to execute some arbitrary line of code or peek at data within the program, which might be used to give you a clue. And I guess you could argue that you could merge this with reverse engineering, since you are sort of figuring out how a program works in order to get a vulnerability. But but there is a little bit of a difference there. And so kind of like what I said. So common exploits are like stack overflows and no input validation. And when I talk about stacks a little later, I'll talk about what a stack overflow means very briefly. And I put that last bullet point there. One of the pitfalls of the C programming language. So when you're doing these challenges, and say a program uses C. C has a lot of memory pitfalls, and as a result of the fine grain control it has over your operating system. But in turn it is quite powerful, and so I will get to a little bit of that later here. So kind of like what I mentioned, reverse engineering is similar to binary exploitation in the fact that you are analyzing a program, you are understanding a program to see how it works. But I guess you could extend reverse engineering beyond just finding vulnerabilities. You're finding how a program works, and and this is really interesting in the real world and quite useful. If you don't have access to the source code, or maybe you found like a 20-year-old game and you want to mod it or patch it without the source code. Just knowing how to analyze the binaries or a program without being given the source code, but only the machine instructions. Is quite handy. Or also, for example, you can use it for malicious purposes. Maybe there's some DRM software on a service. If you with enough effort, you can definitely reverse engineer it. Of course, things have definitely gotten harder these days, but it is definitely still possible. And so, kind of like what I mentioned, in CTFs, you still try to figure out how these programs work in order to get a flag or figure out a vulnerability. And so, so kind of an extension of binary exploitation. You typically use something called a debugger and disassemblers, and those will kind of give you, what it looks like to the computer, or at least, at a very, very close to hardware kind of level. And I'll get to that a little later, especially the assembly part for disassemblers. So yeah, cryptography. Oh, I guess I didn't take that up. So cryptography. I'm sure most of you are kind of familiar, at least with the bare bones definition of how, what it means. How many of you here know, at least have a brief understanding of what it means? Okay, fair enough. So most people do. But in these challenges, cryptography, right? So typically, when data is being encrypted or secured, in these challenges, there's typically some underlying or overlooked flaw, and and it's kind of your job to figure out what that flaw exactly is, and how to exploit it. And so, typically we encrypt or secure or I guess transmute in a way data through ciphers or or different schemes. And so, for this presentation, I've kind of outlined a couple of schemes to talk about, though, I won't go, I'll try not to go terribly deep. But, just to kind of, but I'm mostly teaching you these because we're going to see them in a couple of our example challenges a little later on here. And so, so I think the next slide is, so it's probably, let me see. Yeah. Oh, I guess I swapped that. So I guess before I could go to the next slide. Forensics challenges and CTFs. They're typically just where you're given a file and you kind of analyze the contents. It's not exactly a binary. Like it could be, an inconspicuous image file or an audio file. Maybe you're trying to find some information within the metadata or something that's hidden in plain sight. No, I guess it's more of a steganography thing, but typically the point of forensics is to kind of look deeper or look thoroughly through some file. But yeah, here, I guess, yeah. So I sorry about that. I kind of swapped the slides, but this is one of the encryptions or ciphers we talked about, and it's kind of a basic one. It's called ROT13, and so basically what that means is that for every letter in a word, the letter index in the alphabet is shifted by 13 characters forward. So for example, right, A becomes N, B becomes O, C becomes P, so on and so forth. So like that example right there, CompTIA is really awesome. Would be translated to this kind of garble that I can't really read. So another scheme here is called base 64, and so basically, what base 64 is the reason it's called base 64 is because we kind of have this set where characters are represented in a series of 6 bits, and if you take 2 to the 6, that is 64 possible characters. So that's why we call it base 64, because you can fit 6 bits of information into it. And so so yeah, typically we'll use like ASCII, and then we'll use this base 64 to kind of convert it to its equivalent. And I guess I don't have a table with me here, but I have a little example here I can kind of show you and talk about a little. So here's an example, right? So let's say we take the word mantissa, and I guess before I start diving in, are all of you familiar with how ASCII works? Somewhat. I'm seeing some shrugs here and there, and maybe some thumbs up. Okay. I guess a brief recap, right? So essentially, ASCII converts a character to its binary equivalent or number equivalent, or how it's represented in the computer. So what I've done here is I've broken down the word mantissa into each of its. So technically, right? They're all like it's broken down to sections of 8 bits or I guess 2 hexadecimal digits. I'll talk about binary number and hex systems in a bit, maybe, so that you can understand this a little better. But for the sake of base 64, I've kind of broken this down into 6 bits, and so when we use this base 64 table, we'll notice that 011 is B, and 010110 that is W, and the capital W, and so on and so forth. So the only issue is, like, what if you have what if the number of words or total bits is not exactly divisible by 6? Well, typically what will happen is when you have like these like little sections, right, you'll try to pad it out with zeros, or you'll have some extra padding because you can't really fit. You might not be able to fit everything within 8 bits. So a kind of an easy way to tell if it's base 64 is there might be a little padding sometimes, and padding is almost always represented by the equal sign in base 64. Though it's also kind of easy to tell because for a fact that base 64 will, and I didn't mention this, but base 64 will only be, I believe it is only represented by numbers and the alphabet, which is lower or uppercase, and then a couple of smaller symbols. So it's kind of easy to tell when exactly where exactly base 64 is. So I didn't talk about the exclusive OR cipher. I was going to, but I don't think we'll be covering a problem on it today for an example. But if anyone's curious, I can kind of explain it a little later. But I'll go on ahead and move on to skills I would recommend for just to prepare yourself for capture the flag events. But before I go ahead and move on, does anybody here have any questions? Anyone in the stream chat? No? We're all good? Okay. Yeah, so I've got so basically these are kind of a guideline. Now, don't take this as gospel. There's definitely a couple of exceptions here and there. Like, for example, right? Like, like if you're not really doing reverse engineering or you don't really have an interest in it, you might not really need to know assembly. But I think for the sake of having a more well-rounded toolkit, I see that there is definitely value in understanding, how basic computer organization looks like, or what the stack is, or lower level languages like C, and of course binary and hexadecimal number systems. I guess I just want to ask really quick, since I didn't include this slide. Firstly, is almost everyone here familiar with the binary and hex number systems? Yes? Okay. And what about the command line? Is almost everyone here all good with that? Kind of? Yeah, don't be too worried. When I go over some command line stuff, I can kind of talk about a couple commands, and we can go over those when I'm actually doing the challenges. I'll be using the Pico CTFs. So so kind of like what's nice about Pico CTF is not only do you have this wide array of challenges, but you also have a nice shell, and you can do a lot of your work there, and it's quite convenient, and it's definitely nice for people who don't want to install Linux, or they don't want to install some flavor of command line for their system. So it's definitely quite convenient. But getting back on topic. Yeah, so again, don't take these as gospel. They're just general guidelines. So I'll go I guess I repeated that one twice. So I'll go ahead and start with the first topic. So knowing a scripting language. So I personally think that whether or not like even for most CTF sections, I think just having an understanding of how a scripting language works is really, really handy. It definitely makes things a lot easier. So, for example, like what if you want to convert, like each character inside of a string into its ASCII equivalent? Well, sure, you could look up on the internet, and you could do it by hand and slowly kind of figure it out. But why would you want to waste the time and effort when a scripting language can do that for you in less than 2 lines? It really does help to ease kind of efficiency, and and it's not only good for just CTFs, it's also good for just having this well-rounded computer science knowledge. Just knowing a good amount of programming can also get you some software engineering jobs if you're dedicated enough, that is. But for our case, I went ahead and chose Python for our case. Mostly because it's kind of easy to understand, and I would argue it's the closest programming language we have to English. Maybe not exactly 1-to-1, but it's close enough that you can kind of see what's going on, even if you don't fully understand. So syntax is kind of weird, but I'll explain that when we get to our demo here in a bit. But what's also nice about Python is it just has this giant collection of libraries are already built in. Like you have a ton of like stuff for your math modules. You have random. You have stuff for your operating system. It's quite expansive, and definitely a nice. It's definitely a nice toolkit to have. So I'm going to go ahead and show off a little program here, and I'll walk you through the syntax of how Python works. I don't know if I can pull this up really quick here. I think this works, right? There we go. Sorry. Is the font size acceptable for you guys? It's good. It's good. Okay, thank you. Yeah, I had some font problems previously. But here, I'll kind of walk you through the syntax of Python here. So, oops, I guess I didn't finish that. I kind of explain what's going on here. So, kind of what I discussed, we can import libraries through the import keyword. And if we want, so when we do this, we have to call the module through random dot something. So because random is kind of like the module name, so we have to call, if we're calling functions from that module, we'd have to do like random dot whatever the function name is. So like if I want like a range of a random range of numbers from 0 to 3, I would do random like dot range 0, 3, or number in range. I don't quite remember the syntax, but it's quite close there. But yeah, so we can, so we have, so like in most programming languages, we have variables. You know, we can, so Python has kind of a weak, I believe, weak type system. So that means you don't have to explicitly tell Python that this is going to be a string, or that this is going to be a Boolean, or that this is going to be a list. You can just tell, you know, you can just say, oh, hey, look, this is just have this variable, and this exists. You don't really have to tell explicitly what that object is. And so what I've so we take input. An input by default is string. So if we want an integer, what we would do is we'd actually typecast that into typecast that, and we can do that in Python by the following here. Sorry, 1 second. I hope that's good enough. Oops. Yeah. So yeah, basically, sorry. So basically, what I've done here is that I can use ints to kind of typecast that as an integer if I'm taking integers, that is. But I don't want to spend too much time on this. There's probably more pressing matters. So I'll go ahead and do that. Yeah. So we can also in Python we can also print things through the print command that's built into the language. And what I've done here is I've used this f to kind of format my input. So what this does is it takes the string right here, right? The input string that we've stored in this variable, and then it prints it out here. You know, there's other ways of formatting strings in Python, but you know, this is quite easy to understand, since all you have to do is just put an f, and then in curly braces you put the variable name. It's not like in other languages where you might have to specify a type. Sorry, guys.
Test. Okay, perfect. Because of Python's weak variables, what would happen if you were to reassign a variable type that's already been defined with a certain data type to another data type?
So I believe. So I guess that kind of depends on the type, but I think for the most part, like if I do, like for example, that if I have that CompTIA variable like this, and I assign that, you know, and I just say CompTIA is just 1, like here, 1 second. Like if I just do that, right? Like I believe that is perfectly valid Python syntax, and I can go ahead and check here. I could probably run it through the command line here. 1 second. Sorry, 1 second. Yeah, sorry, I'm not the best at Visual Studio. So here, I'll go ahead and run our program. Let's check if that's fine. Oh, I have to remove that semicolon first. Oh, my bad. I think I forgot to comment out a little block here. Yeah, that one. That's the problem. I'll come back to this. And so I'll say like A, for example. I'm just being lazy here. Oh, but C, take a look. So actually, well, so kind of to answer your question, so I believe that is legal, but what I've you know, because I've concatenated this, the way Python handles this is that I can't. So when you're combining two strings, that's what we call concatenation. So you know, in Python, you can't really concatenate a number or an integer and a string. So you'd have to convert that to a string using str, and then enclose it with parentheses. But I believe this line here is acceptable. But the problem is this line. You know, I believe that's correct. If anyone in the audience wants to, you know, correct me, you know, feel free to jump at me for it. But I'll go ahead and continue here. So I don't want to spend too much time here, but yeah, I can cut that line out. So what I'm doing is I'm taking this variable and then I'm concatenating it, which means combining these two strings, and then I'm printing CompTIA is with us today. And so I've got that. And so Python also has some other data structures, like for example, lists. And for those of you who don't know, so lists essentially, they can store like a series of objects within one variable. With Python, lists aren't actually restricted by just one type. So for example, right, like you can have an integer, but you can also have a string, and for and an integer is just a regular number. It's not, it's like 1, 2, 3, 4, 5, 6, so on and so forth. But you can put integers and strings in the same list, and that's perfectly valid. And here I have a Boolean, well, it's a variable, and I'm assigning it a Boolean. So Booleans are typically only true or false. They kind of, they represent a truth or validity of a statement. And so just to kind of expand on lists more, because they're quite handy in Python. What I've done in this is I've called the append function from Python's built-in list library, and I'm appending this string onto the list. And so what I've done here is that if this variable, if this string is inside, oh, I guess I have that wrong. It should be here. Actually, I should change that really fast. Oops. Yeah, sorry. So you can simply do this, and it'll check if that item is in the list. And so in this case it does. So it should print ACM does exist in the list. But if it doesn't, then what it does is it prints that it isn't in the list and asks why. I guess they can do that. But then it also appends this pi. And so kind of what I was talking about earlier is that when we do this statement, I don't have to specify math.py. I can just say pi, and I can just append it to our list. And so here what I've done is I've just printed that list, and it'll just print the contents of the list. So in this case, it'll just print ACM with surrounded by these brackets. So what I've done here is that so just to continue on, so we also in Python we have a data structure called a dictionary, and what a dictionary is that it assigns a key to a value. Now I think the key doesn't necessarily have to be an integer, like it can be a string. But in my case, I just made this very easy, and what I did is I mapped numbers to a couple of organizations. So like for example, CompTIA is 1, 2 is mapped to Rowdy Creators, 3 is mapped to, or I believe it's the opposite way, excuse me. Rowdy Creators is mapped to 2, ACM-W is mapped to 3, Code Quantum is mapped to 4, and so on and so forth until the end here, which is just RowdyHacks. And then I'm taking the, so for every item in the dictionary, I'm just appending it back to our organizations list, and I'm printing that list again. And so just to show you what's going on, I will go ahead and run this program. So I'll come back here. Oh, oh yeah, sorry. Or I probably didn't spell it right. Whoops. Oh yeah. So I think what I've done, yeah, actually that makes sense. I kind of reversed the order of the dictionary here, but yeah. So you'll see obviously kind of what I explained, that ACM does exist in the list, prints it out, and then in that little dictionary for loop statement I had, I've reversed the key and the value. So that's why it's printing a 1, a 2, a 3, a 4, and 5, and 6. If I reverse this, then it would print each organization's name. And so I think that covers it for the basics of Python, or at least at a rudimentary level. Does anybody have any questions? I hope I didn't go too fast here. Everyone's good? Okay. Yeah, Boolean. Yeah, or yeah, I think Boolean's right. Sorry. But
Repeat the question.
Well, yeah. What's up? Oh, sorry.
Repeat the question into the mic, please.
Oh, I'm so sorry. He asked, or he said, I guess he made it more of a statement. It's he didn't know it was pronounced Boolean, so I guess he made a statement there. Sorry to chat there. I'll go ahead and come back. So that was our example. And so I want to transition to C really quick here and talk about compiled versus interpreted languages. So in Python, we like what we've been doing is we've been working with an interpreted language. And essentially what an interpreted language is that you have this thing called an interpreter. And what it does, it'll process and execute instructions as it receives them. And so you know, some programming languages, you know, have interpreters or use interpreters to execute instructions on your computer. But there are other languages which are called compiled languages. And they're a little different because compiled languages, what they do is, you know, all the analysis and all the linking of your binaries and all, you know, like, you know, translating it all to machine code such that the computer can actually read it, that is all done beforehand. Once you execute the program, it kind of already knows that, okay, these are exactly the instructions I need to follow. You know, unlike an interpreted language, you have to kind of wait and for each instruction to come and execute them. And typically, it's for this reason that you kind of still need to analyze each instruction in interpreted languages, that they're a little bit slower. So that's why the importance of C comes in. So, you know, like for example, if you're dealing with like a very, very long number, like let's say 2 to the 32 or 2 to the 16, like that's a big number, isn't it? You know, like I believe 2 to the 16 is like 65,000, right? And you know, now Python could probably handle that, but what if you go 2 to the 32 or 2 to the 64? You know, now Python might have some issues trying to process such a large number. So having, you know, a language like C or you know, I guess by extension, other languages are probably better at handling that number. But you know, for our purpose, I'll just use C as an example. You know, C kind of has that power to you know, because it's a compiled language, it doesn't have to spend all that time processing such a long and large digit. And you know, I really want to emphasize the importance of C here for you know, some of the lower level challenges like reverse engineering and binary exploitation, simply because that C gives you this very, very fine-grained control of the operating system's internals. So like memory management, you know, because Python and most languages, they kind of try to hide that from you. And while they do, you know, they don't really, like, I don't believe Python has direct access to pointers, right? Like that's not something that's really there. But in something like C, where you get to, you know, where you get to manipulate, you know, portions of computer memory, right? And you really might want that at some point. You know, having said power is you know, is really, really helpful. However, you know, the main pitfall with C is that, you know, while you do, I believe I have a slide. Oh, I guess I don't. So the thing with C is while you do have all this power, to, you know, to manipulate memory, you know, quite extensively in the computer, the issue comes that, you know, if you're careless about it, it's very easy to abuse. It's very easy to abuse. You know, and you know, you might run into some issues. You know, if you misuse memory management. So I guess my question now is, you know, how many of you are sort of already familiar with C? I'm aware there's a couple CS people in here, so most of you are, a good amount. For the sake of this presentation, I'm just going to head and review it anyway. So what I've done here is I've just created a very simple example in C, just to kind of you know, take a brief overview of the syntax here. So to start off, we have those include statements. So they're a lot like Python's import statements, but the sharp actually tells it that it's a preprocessor directive. And essentially what that means is that it kind of comes before the compiler, or actually compiling your code. It sort of just reads that off and says, oh, I know what to include, or what to state. And so these sharps, you usually find them in include statements, but you also find them in something called a macro. And macros essentially takes some constant, and in the code, what it will do is it will replace any instance of this constant with its number, with the thing that it's being assigned. So in this case, time of workshop. So if I use it at any moment in my code, it will be replaced by 2. And so I do have the structure, a data type that I want to talk about a little later, but I'm going to skip over that for now. And so, like in Python, we can assign variables. However, we do have a stronger, stricter type system that, we have to tell it it's an integer, or we have to tell it it's a character, which, just basically means a letter, or we have to tell it it's a float. So you do have to be explicit. And moving on to input. So input is a lot like Python, or somewhat, where you take in values. But of course, I guess here you have to actually specify that you're taking in an integer or a string. And you see this ampersand. So what that means is address of. And I'm gonna get to why that's important a little later on. And so here we're just printing the input number that the user has put. And so here we're just using the printf statement to print off these values. And that \n is just an escape sequence. And that %d is just referring to an integer. And that and printf allows you to specify the order in which these come in. So, like this is that first variable afterwards, A, and then this is B, and then that's D, or at the very end. So I also added this reminder for memory capacity. So each data type has a certain amount of space it takes in memory. And while this does differ by architecture, kind of depends on what computer architecture your system is running on. For the sake of my example, I believe this is something called x86, which is run on most modern computers. But I believe in x86, integers are just 4 bytes, which means that is that's like what, 32 bits? Yeah, that's 32 bits. Characters are 1 byte, so that's 8 bits, and so on and so forth. Floats are 4, and doubles are 8. So I don't want to spend too much time on that. So we can actually, so kind of like in lists in Python, we also have arrays. Now arrays, again, you do have to specify the type system, but you can also specify capacity. So what I've done here is I've just made an array of 5 elements, 8, 7, 6, 4, 5, or I swapped those, I guess. So they're 0 based, and what that means is that to address this 8 right here, we have to do 0. If we want to address this 7, we have to do 1, then 2, then 3, then 4. So you don't actually have, you can't actually do like R5 and reference that 5. You have to do R4 because it starts at 0. And so kind of like in Python, we can use for loops. I didn't talk about this, but this is a way to iterate through objects. I assume most of you are familiar with for loops, before coming here, but we can iterate through them, in C, where we create a local variable, call it I, it's an integer, check if I is less than 4, and if it is, increment. And what we're doing here is just printing each array element forwards, and then we print that last one there. And then there's also while loops. In this case, we're just printing the same thing except in reverse. So strings, they are basically just character arrays. So think of it as like an array, and each section is just one character. Now, the length of CompTIA is exactly 7 characters, but you might notice that I've assigned the size to 8. And now you might wonder, why exactly is that? So the thing with C is that it has a little character at the end, and we call that the null terminator. I believe by value that is simply just a 0, in the actual computer. So what that means is that it tells the program where exactly that string ends. So, like it's represented by this. So that little section there, that's what we call the null terminator, and that's where it knows it's the end of the string. So I think it's mostly self-explanatory. Is everyone still on board? Okay, good. And so now I actually want to get into pointers. This is the, like, if you learn anything, or if you learn anything, this is the big takeaway right here. Essentially, what pointers are is that they're just variables that point or refer to some location in memory. And so you notice that I talked about that ampersand preceding a symbol here, and essentially what that means is address of. So in memory, so you'll kind of, so it means address of, so it's not actually an integer. And so the reason I've assigned it to like this, right, is because the little asterisk there means to dereference. And when you dereference a pointer, that means you're getting the actual value out of it. So like you'll notice in this line, I haven't dereferenced it because I want to assign pointer to A as the address of A. So it points to whatever the address of A is inside of the memory. And then I'm saying, okay, we'll change the value. So dereference pointer to A and change that to 16. And so now, because it points to A is also changed. And so when I run this program, you'll see that we have A and then address of A, and then we can kind of see that they're the same. And also, pointers are interchangeable with arrays here. So if you just refer to it by itself, that is just the 0th index, and then or +1, and then with a pointer or dereferencing it, that is just the first index. And kind of what I mentioned earlier, the structures, essentially they keep like it's just one variable that encloses a heterogeneous, it encloses several types of variables within that structure. So I think if I scroll back up here, you'll see that this structure organization takes in a character array that's 50 characters wide, some integer number of members, and then the type of organization. So what I've done here is I've created an instance of that structure, and then I've assigned it these values. Now, in this case, I use string copy because you can't really directly assign it. I have to use that in order to copy that over, and that's a function which I can talk a little bit about later. But I might skip because of time here. And so I'm taking that and I'm printing it, and then I think that's mostly self-explanatory. I'm just calling it a function. I'm using that as a parameter. And so now also the big takeaway is memory allocation. So essentially so what we've done up to this point is we have put these variables and now we've allocated into memory, but we've allocated it into an area called the stack. And for our purpose, I think that using the stack is perfectly justified because we don't really have many variables. It's perfectly acceptable. But what if we want more memory? What if what if we're dealing with a large amount of memory? Well, that's where something called the heap comes in, and the heap is where you store all the allocated memory in. And so we can allocate through the heap in C using these functions called malloc and calloc. And so what I've done here in our example is if we want to store several structures, what I've done is I've allocated memory for the size of this, for the size of the structure multiplied by 3 because we want to store 3 structures in it. And so, what I've done here is I've just assigned each so I've assigned three organizations here into that structure, and then I'm just printing each structure. But then also at the end of each allocation, you have to free that memory, because if you don't free that memory, it's still going to be there, and it'll cause a memory leak. And I believe, so I mean, when you close down the program, I believe it's not so much of an issue, but it's still kind of a concern to be aware of. And now I guess I'll go ahead and run the program here, which I can do that, which I think I can. Okay. So I believe it takes an input as a number, so I'll just put 1. And then, as you can see there, I've printed each organization, and you'll notice that type of org is 0, 1, 2. I've used something called enum, and what an enum does is basically it's a way of like referencing values and grouping them inside of a very simple data type. Now, I hope that's good enough to cover for C. Is that good with you all? Now, I know we're running short on time. I really kind of want to get to the good part here, as you know, I'm sure you've all waited for it. Now, yeah, I've talked about the stack. Essentially, it's like think of it as like a stack of plates where you can only modify or push in or add the member that has been added to the latest. Yeah, and assembly will knowledge of the stack is very handy when you're dealing with not just assembly but also some of these reverse engineering challenges we find. But now, sorry, but for the brief overview of stacks, but I actually want to get to the challenges now. So I assume you guys have signed up for, or at least those of you who want to follow have signed up for Pico CTF here. Firstly, so this is just a really, really easy challenge. So we're just given this description, and then they just tell us that cryptography can be easy. Do you know what Route 13 is? And I think that just says it all anyway. But while we could just hand solve this, right? We could convert each and every single character into, or we could decode, or we could, we could subtract 13. Because we're reversing the cipher, we want to subtract 13 instead of add 13. We could individually do that and figure out what our flag is. But there's an easier way with Python here. So what we can do is we can actually use a Python library and figure this one out. So I'll go ahead and show that to you guys for a sec here. So here I pulled a Pico CTF, and so here, so what I'll do is pull up the challenge here, and so I'm going to pull up the web shell here too. Give me 1 second. This mic does not want to cooperate. Oh, my bad. Swap over. Okay, so here, sorry guys, hold on, go on ahead and pull the shell up. Here, might be better if I just drag that tab over. Yeah, so here, so we're gonna use the shell here just to make our life easier. And so what I'm gonna do is I'm going to use a Python library called Codex, and I'm going to take this message and decode it. So, so I'll kind of show you what I'm doing here. I guess the mic doesn't want to cooperate still. So here, we have this key. So I'll go ahead and copy that key, right? So, and then, what I will do instead of actually writing a Python program, what I will do is I'm just going to open up the interpreter because we're lazy. And so first thing I will do is I will go on ahead and import the Codex library. So import Codex. And then what I will do is I will do code, or I'll set A equals to our string here, which, hold on. So I've assigned A to that. And now what we will do is we will call the Codex library and then decode. And then we will take an A, and then we will tell it Route 13 scheme. And so take a look. We have our flag, and kind of like what I mentioned earlier is we can tell it's the flag because Pico CTF will say that the flag is Pico CTF or starts with Pico CTF, and it's enclosed by curly braces. So as you can see here, we made the work so much easier on ourselves. Rather than having to hand convert each and every single character, we simply just use a Python library to do all that work for us. So in simple tasks like these, right? Using Python, it just saves you so much time. So I'll go ahead and swap over And then what I will do is I will paste this flag in. And take a look. We have solved the challenge. So let's see if I can swap over to our next problem. So here we have a slightly different problem. And essentially, you're given this string of numbers, and you have to kind of decode it. And you're not really given much information, but what are some things you guys can pick apart from this? Janelle. That is true. There's one very key thing that I'm not sure if you guys can see it back there.
Is it just the alphabet?
That is true. It is. If you will notice that so we know that so Janelle here, she mentioned that that's the flag. And that is true. We know that is enclosed by curly braces. But we also know that the first 7 letters are Pico CTF, and Pico CTF has 2 C's, and you can clearly see that C is you can clearly see that there are 2 3s appearing. And then we also know that C is the 3rd letter of the alphabet. So we can obviously kind of tell that this is merely just the alphabet into its number equivalent. And so now while we could, decode this, what I am going to do is I'm actually going to make this a lot easier. So I'm going to open up our web shell here, and I'm going to make a script that will decode this for us. And of course, I'll probably exclude the curly braces, but I'll make it easier for us. So let's swap on over. And so I think what we can do is here, I'll just go on exit, open it up again. And so I hope that doesn't fall. So what I'll do is I'll first put all of our numbers into a list. So we'll say, nums. And then we'll say that 16, 9, 3, 15, 3, 3, 20, or whoops, 26, 6. Or actually, we already know it starts with Pico CTF. So we'll go ahead and input what's inside the flag. So now I will use a handy Python function called so for actually what I'll do first is I will make an empty string so we have something to work with. And so what I will do is I will make a for loop. I'll iterate through each value, and what I will do is I will add 97 to it. And you're probably asking, well, why would you add 97 to it? So if you know the way ASCII works is that we start all of our values. So you know that A, B, C, D, E, F, G, those all start at so those will all start at 97. So 97 is A, and then 98 is B, 99 is C, so on and so forth. So we're just going to make this easy and use something I believe called ORD, or maybe is it CHR. But I will convert these numbers into their ASCII equivalent. So here, 1 second. Or actually, well, that is I think that, oh, actually, I forgot something important. Sorry, guys. Hold on, sorry. I think I might have messed that up. Here, yeah, I guess it kind of messed up there, but so what should happen is that here, why don't yeah, so or actually isn't, maybe it's 96. Oh, well, actually I know what I did wrong. I'm blind. Sorry, guys. Or actually, no, I'm probably just going to move to the next challenge. I don't want to keep you guys here for too long. So yeah, so basically the approach I took here in our case is what so we obviously know that these are just the alphabet numbers, or the alphabet indexed by numbers. And so what you could do is you could take each value and then add 96 or 97, I think, in its ASCII form. And then what you could do is you could use a function to convert that into ASCII characters and then append them all together. So you just get the inner flag, and then you can copy and paste it. I hope, was that approach clear? Or I hope, good? Okay. And lastly, or whoops, I guess I didn't change that title. But lastly, we have this forensics problem here, and they give us a file called cat.jpg, and it's just asking us to find the flag, and we don't really know much. So I guess what we'll do here. So we'll go ahead and take a look at the file here. So I'll open up terminal again. So I believe I already have it here. So let me see if I do have it. Okay. So yeah. So let's go back to the challenge and see what we're given. So our hints are that it asks us to look at the details of the file and then make sure to submit the flag as this. So we know for a fact that this flag, well, I mean, it will tell us what the flag is, but it tells us that whatever is inside is what we need to concern ourselves with. And it obviously says, look at the details of the file. So we obviously have an image, right? So what we can do is we can look at the image and see what it tells us. So we can open up a hex editor, which will like decompose this into binary, right? And typically the de facto editor for Unix is XXD. So I could do XXD and then cat.jpg, right? And so we're given just this large string of hex values. And maybe if we scroll up, right? So, it doesn't look like there's anything particularly interesting here, right? So, I don't think there's any information there, but what if we use something called exif tool and we look at the metadata of the file, right? So if we do that, and then we look at cat.jpg. So let's look at the information here, right? So, all of this seems kind of normal, right? So, you have your notice, you have, how the JPEG was encoded, you have your image size, your resolution, your bits per pixel. But if you look at that license variable, does that look off? Do we agree it looks off? Right? Okay. Well, actually, yeah, that is our key. So if you so this is actually encoded in base 64. And so what we can do is we can take that and we can decode it into its equivalent. So let's go ahead and do that. So I'll go ahead and try to use Python again here. So what I'm doing here is I'm using the library to decode our base 64 string here. And would you look at that? That's our flag. So if we take a look, oh my bad. So if we take this flag and we copy paste it in just to verify our answer. We have our flag. So yeah. So I don't want to. So I want to finish up here. But before we end, I do want to inform you guys that we have a whiteboard or mock. We have a tech mock interview workshop going on next week. I guess that's today. I'm so sorry. I'm so sorry. It's a little last notice, but if you'd like to go there, they're still up for, I don't know, about 50 minutes, 45 minutes. I can't believe I didn't caught that. But yeah, but you can. It's a little late, but I don't know if you can RSVP here. I mean, if you want. But before I conclude this presentation, I just want to say a huge shout out to CompTIA, and especially to Ryan here. She has done a very, very great job working with us. So thank you. And that's it. I appreciate your time, guys. Thank you.